Hello, we're back for a part 2 here for the renewable energy. I just thought it was going to make a really long video, and so I figured we could break it up. Also, I don't know if you knew this in my class, folks, but I can look at the YouTube analytics and see how long you spend watching the video. So if you're taking notes, how are you doing that if you only watch like 20% of the video? Okay, so just so you know, I know. And that's where you're going to get the information from. So, and if you're going to take a test or anything. Anyway, back to reality. Hold on. There's my other child. She wanted to be in here. So, what about biomass? What's biomass? Well, bio means life, right? And mass means mass. So, biomass, you're talking about like, formerly living things. So we're talking about things like trees, stuff you can burn, like that. So a lot of the world's population relies on biomass for their energy. So like they rely on burning wood. But the problem is if you burn it faster than you can replenish it, then you end up adding greenhouse gases. So like if you burn more trees than are being planted and growing, then we're going to have an increase of CO2 and greenhouse gases, which is bad. And if you make a biomass plantation, so like you have a tree farm that you're just going to use so you can cut those trees down and burn them, that's a great idea in a sense, but the problem is it degrades soil and you lose biodiversity, which is a bad thing. Lower biodiversity means less healthy environment. So that's not good either. We can use things like liquid biofuels that you get from biomass instead of gas or diesel. But making a biofuel plantation is the same thing. You create something called a monoculture. Mono means one. Monorail. Mono means one and rail means rail. A monoculture means one crop. And that's going to hurt the soil, and you're going to decrease biodiversity, which means you're going to hurt the other animals and plants that could be growing there. And then in that spot where you're growing plants for fuel, that's where you could be growing food. So you're going to increase food prices, and you're going to increase greenhouse gases. So there's a trade-off to that. So what is biomass? It's plant materials or animal waste, like literally like poop, that we can burn or turn into biofuels. So how can we do that? You can plant fast-growing trees. You can have tree farms with biomass plantations. It's a tree farm. You can collect crop residue and animal poop. So like, think of the farm that's right next to the school. I know I'm pointing like it's like I'm there. But think of how there's like the little farm right next to the school. Well, they'll sit there and they'll have their crops and everything. But let's say they're growing, they grow different things there. Some use cotton, some use it's tobacco. Let's say they grow cotton. We just want the little fluff part. What do you do with the rest of the cotton plant? You got to get rid of it. So you could collect that stuff and burn it for a fuel, right? So that's what we're talking about there. So remember, you can always pause and look at the trade-offs here, the advantages and disadvantages. I'll kind of go over them quickly, but if you need to write stuff down, pause the video. So biomass, what's good about it? It's everywhere. It's everywhere. It's trees. The cost is moderate. It's not super high. I mean, it costs something to grow a tree or have a tree farm or have loggers come in and then ship it and cut it and whatever you have to do with it. If you are doing this sustainably, so for every tree you cut, you replant trees. So you're replanting as you cut. If you do that, there's no net CO2 increase. So you're not actually technically adding CO2 to the atmosphere. You are, but you're pulling it out with these trees as fast as you're putting it in. Okay. And then if you, let's just say someone blows up the side of a mountain to get coal, well, if you're going to replant some trees there, it can actually help restore lands that have been ruined by humans in some other way. Well, okay, this sounds great. Well, what's bad about it? You have a lot of environmental impact. Like, have you ever seen someone clear cut a forest? I've seen it happen. You drive down, I think I was driving down 64 and all of a sudden I'm like, what's different? I'm like, oh, they cut down all these trees. So what about everything that lived there, all the birds, all the little mammals, all the bugs, all the other plants that were there? What happened to them? They're gone. So, and that's just in one little area. Usually things are not done sustainably, so because of that, you're going to increase CO2. If you clear cut a forest, what's going to happen is it's going to increase erosion, which is the movement of like soil from one place to another. So that soil is going to move. It can actually cause desertification, which sounds delicious, but it means it could become a desert. It's going to increase water pollution because all the water, instead of getting caught and soaked up by these trees and grasses and whatever else, is going to run off into whatever is there, whatever creek, river, water supply that's there. So you're going to get increase of pollution into the river. And then obviously you have a loss of wildlife habitat. So you're going to lose animal and plant life. That's bad. And then it's the way that we burn it is often inefficient. They just kind of make a fire or like a little stove or something. And it's also not great. It could end up harming the people that are breathing in that smoke. When they're doing it in like a little kitchen or whatever. So that's not great. But we can turn those things, like we can get wood, like you collect the wood, we can, not wood necessarily, but we can turn biomass into liquid biofuels, and that's biodiesel and ethanol. And so the biggest producers of biofuel, actually, it's us, and Brazil, the EU as a whole, and China. So advantages of using that instead of gas. These biofuel crops can be grown almost anywhere. Oil is only available in certain places. If you manage this properly, you don't increase the CO2 in the atmosphere, which means less greenhouse emissions. And available now. Call 1-800-441-2400 for 10 easy payments of $99.95. Do they still have those commercials on TV where they've got the guy telling you, back in my day, it was like music compilations. It would be like Pure Moods Volume 1 or Secret Love with like soft rock favorites. Okay, those things existed. One day I'll have to show you guys. You probably know what I'm talking about. Kids Bop. Do you remember? Do they still have commercials for that? I don't have cable, so I don't know. Okay, anyway, back to reality. What about problems? Remember, so if I'm just planting, let's just make up bamboo. Let's just say I'm just planting bamboo. Well, the only things that can live there are things that eat bamboo and can grow around bamboo. And if I'm growing it to harvest it, I'm going to try to pull up any other weeds or anything else so my bamboo grows really well so I get the most crops that I can get. So that leaves very little room for anything else to live there. And if you remember from biology, everything is like interconnected, right? In the food web, in those nutrient cycles, we rely on all the different creatures that you can and can't see, even the little teeny tiny guys, the little microbes in the soil, to work together and keep the environment healthy. When we just plant one single crop, we lower that thing called biodiversity, and we end up having a less healthy environment because there's fewer different types of creatures there. Like I said before, you're going to increase soil degradation. That means the soil is going to get kind of crappy. If you know about agriculture, you know you have to rotate your crops because certain crops will pull nutrients out of the soil, and other different crops might be able to pull it back, or they'll be able to use a different type of nutrient that's in the soil. So you're going to end up like kind of wearing out the soil. It can push farmers off their land because you're like, okay, well, we're going to use this land here just for growing biofuels and not food. So you got to go somewhere. And that could cause an increase in food prices. And then you're going to have less water because things like corn and soy, which can be turned into liquid biofuels. That's why we have so much corn that we grow. It can be turned into ethanol. Maybe you remember at the gas pumps, you might see it where it says ethanol free or contains 10% ethanol. Well, that comes from corn that we grow. But things like corn and soy need a lot of water to grow them. So then that water is less for other crops and less for people. And in places like California, where they have droughts a lot of the time, it's not great. So see how these things connect to each other. So let's look at trade-offs for biodiesel. Hey, you reduce carbon monoxide, that's CO, and CO2 emissions. You get a lot of energy from palm tree oil, but do yourself a favor, research or look up palm tree farms and why they're bad. Why are palm tree and palm oil farms bad? There's a huge controversy about them. There's less hydrocarbon emissions. That's things like CH4, methane. That's good. We don't want those gases in our atmosphere. And you can actually get better mileage with biofuels. How about that? So what are the bad things? Well, you might reduce the carbon emissions, but you're increasing what we would call NOx emissions or nitric oxide emissions. So that could be NO2, NO3, and smog. Smog is like, this like nasty cloud of gases that forms kind of lower to the ground that we might have to breathe in. So for soy, you don't get a lot of energy from that. Palm oil, you get a lot of energy, but soy, which we can grow pretty easily, you don't really get a whole lot of energy out of. It competes with food for cropland. And then clearing the area for plantations reduces the natural biodiversity, which is eventually going to lead to an increase in CO2. So not great. So ethanol is like one of the main liquid biofuels that we use, and we get it from corn. So you can look at that, but I'm not going to go into all that. Brazil uses sugarcane instead of corn. So you can see here that the world has been increasing their production of ethanol as a fuel source. And here's the like sugarcane residue that you can turn to ethanol. You can use switchgrass, which grows really quickly, as a fuel too. So, okay, so we've got ethanol. You could go to the gas station and see something say contains no ethanol or contains X% ethanol. I think they still show that on there. You'll just have to look next time you're at the pump. So it can reduce some CO2 emissions, like if you're using the sugar cane. You get high net energy from switchgrass, and this is from the sugar cane. And it's potentially renewable, right? So if you can continue to grow those things and rotate your crops properly, you can continually make this ethanol fuel. Okay, we don't have to worry about running out. If you use corn, you get less energy and it costs a lot more, which guess what we're using? Corn. That's what mostly we use. And corn, actually, we're going to end up with higher CO2 emissions. And corn ethanol competes with food. We grow a ton of corn in this country. It's in like almost everything. Don't look, I'm drinking or soda, as some people call it. But the first ingredient in a lot of our foods, especially sugary foods, isn't sugar, it's high fructose corn syrup. We have corn in lots of our foods. We used to have a lot of cropland in this country growing corn. But if we, in turn, take that corn and put it into our gas tank instead of into here, well, then the food price is going to go up because there's less food available. It's getting turned into ethanol. So this deserves you taking some time to look at this. You can always pause and read this, but I'm not going to go over it. But maybe we can get gasoline and diesel fuel from algae and bacteria. So maybe we can eventually use living creatures like algae or bacteria to produce fuel for us. That would be, listen, if you want to be a millionaire, figure out how you can do that. She wants to be a millionaire. It really is. So what about geothermal? Geo means earth, thermal means heat. So we're talking about heat from the earth. So geothermal energy actually has really great potential. So think about it. Think about the layers of the earth, which maybe you remember. If you don't, outside is the crust, then the mantle, and then the core, which is the outer and inner core. And if you remember anything about the core and the mantle, you know what they are like? Hot. Do not touch. We can't anyway, but they're incredibly hot. So the core of our planet is very, 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 very hot. So there's some natural heat energy there. So if we could harness that and use the steam or if we could use that heat to boil water and use the steam to turn a turbine, then we'd have electricity. It usually has low environmental impact, but there's not a lot of places where we have really good access to geothermal energy. So where is this heat stored? In soil, rocks, fluids in the Earth's mantle. And geothermal pump systems are actually energy efficient and really reliable and environmentally clean and cost effective. These sound great. So basically you get like a little pump here. and you pump out the cold air, and here's warm air. We kind of move it through this warm soil, and then it pumps that warm air back in. And then it's actually usually cooler in the summer than it is in the winter, so that's how you remove the hot air and cool it down. Around here, because we're in like a kind of a flood zone, people don't have basements. Where I grew up, all these stories about where I grew up, you always had a basement. We had a basement in the house growing up, and in the winter it was always warmer in the basement, and it was always cooler in the summer. So, I mean, that's just firsthand me knowing a little bit about that. So here's just a picture of what I just showed you. Winter, summer, winter, summer. These things entertain me, okay? You got to entertain yourself somehow. Okay. So for hydrothermal reservoirs, we're actually the world's largest producer of hydrothermal, like hydro water, heat. It can come from hot, dry rock. So what are some problems? It costs a lot to like kind of tap into these things at first. These reservoirs could be depleted, so they could be non-renewable, and it could create earthquakes if we're like kind of digging deeply into this area, into the Earth's crust. Here are some geothermal sites in like mountainous areas and desert areas. Not us. And worldwide, here's where they are. Look, now what's along here? If you remember anything about Earth science. Oh wait, that's this here. If you remember anything from like 8th grade, well, these are plate boundaries. Remember, the crust is made of these plates that move on the mantle. Maybe I'll do some stuff so that way you guys can remember about that again. I think I wanted to do that when I'm there with you guys. That's why I didn't do that. But this area along here, there's tectonic plates. So the crust of the Earth is made of these moving plates that, if they move, that's what causes earthquakes. Here too, this is where you find, this is where the plates are moving. Here too, what's that? Iceland. It's gonna split. It's right on like this fault line. So where you see these fault lines are where the plates of the Earth's crust are moving. That's where you have really good geothermal energy sites. So that's why they're saying this could cause an earthquake, because they're in earthquake zones. Here's a power plant in Iceland. Look at that. You've got this like, it's like an onsen, like a hot springs. And so this area is very warm, and they're going to use that heat from the Earth to boil water, turn a turbine, and generate electricity. And then here you have just like a hot spring. So let's look at these trade-offs. This is the same thing. It's just bigger, I hope. I mean, maybe you can see it better there. Just remember, pause if you want to write this information down. So good things. You have moderate net energy. So after you build your power plant, you get some good energy out of there. And high efficiency where there's a good site for it. There's lower CO2 emissions than with fossil fuels. And it's really low cost in good sites. Okay, if we tried to build that here, it would be high cost and it would not be efficient. So, I mean, that's not a viable answer for us here where we live. There's not a lot of suitable sites to build one of these. And it can mean noise, and there are some CO2 emissions. So it's not perfect. But man, if you're in the right spot, if you're in the right place, this is the energy source that you want to use, like in Iceland. That's like, look, man, but I wouldn't want to live in Iceland. First of all, think about it. Iceland. I'm not about the cold. And it's so far north that in winter, there are times where like they just don't really see the sun. Can't do it. I can't do it. I would need like a sun lamp to live under. But other than that, Iceland would be great. So another energy source that I'm really not going to talk to you guys about, but I'm just going to show you, I can kind of like click through a couple things, is hydrogen. So there's always like, a rumor like, oh, what if we made like a hydrogen fuel cell or that sort of thing? Hydrogen's very flammable. Look at the Hindenburg disaster. When people are like, oh, the humanity, like they used hydrogen as the fuel for that blimp, and it started on fire, and it was a terrible tragedy like 100 years ago. So we don't really have a viable hydrogen fuel cell, but if we could figure out how to do that, that maybe could be a really good source of energy. Basically, you have hydrogen gas, you pass it through some protons through here, and you pass the electrons through here. That's electricity. And then there you go. Air goes in and water comes out. So we're not really going to talk about that, but if you're interested in anything about that, there's some information about it. That's my child. And maybe you heard the other one in the background. So basically, we need to work to a more sustainable future for energy. How are we going to do that? We have to make more energy efficient products like computers and phones and everything that can do the same thing but use less electricity or use it more efficiently. A lot of energy gets lost as heat, or the machines just aren't efficient. That's why you'll see the little energy efficient label on things that used to be bigger. Hold on a second. Hey, Veronica, they can hear you on the thing. You know that, right? Thanks. I like her. So we have to mix in renewables with our non-renewables because we don't have the infrastructure to just use renewable energy right now. And we have to include the environmental cost in the cost that we pay for all of our energy resources. And all of a sudden, it's not going to be worth it to use coal and oil anymore. It's going to be too expensive. And the government will have to subsidize other things. So that's just how we're going to have to do. So we're going to have to create kind of like a smarter grid that connects our renewables and our non-renewables together to deliver our electricity to us. Here's just like kind of an idea of how that would look. And this is like the kind of solutions where we need to go. We have to improve energy efficiency. We have to use more renewables. We have to reduce pollution and health risk. This is my house. This is my cat. So listen, if you can do some of these things, like if you want to think about jobs in the future, if this stuff interests you at all, if you can figure out how to make machines more energy efficient and use less energy and still do the same thing, you will make money. If you can figure out how to make renewable energy resources more efficient for daily use and for widespread use, you will be a millionaire. Okay, so when you're a millionaire, after you figure this out, remember me. Be like, oh yeah, my teacher gave me the idea for this. Okay, so remember me, like that song. Here's the other thing. So the government gets into all this other stuff, right? And it subsidizes things like coal and oil, which means the government kind of gives these companies money to keep the cost of them low. But the government does not do that for things like solar, wind, hydroelectric. So if the government subsidized renewable energy resources, that could bring the cost down, and maybe more people would choose to have something like wind power than they would coal. So here's some things you can always pause and take a look. What are some things you can do if you ever worry about stuff? Because whenever I learned about stuff in school, I would always then worry. I'm like, oh my gosh, I'm killing the planet and blah, 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 blah. I still think about that at times, like how I've got my computer plugged in, I've got a light on here. Anyway, these are some things you could always pause and take a look. These are some little things you could do if you want to like try to reduce the amount of energy you're using. So, big ideas from things to do with renewable and non-renewable energy. We need to evaluate all of our energy resources on how much supply there is, how much she did it. I don't know what she did, but she did it. How much useful energy we get, and the environmental impact. That last one isn't really factored in. So, like, we're not paying the cost of the environmental impacts of oil. We don't pay the cost of an oil spill. We don't pay the environmental impact cost of coal, where they destroy a mountain and like all that plant and animal life is lost. Or we gotta watch this movie about coal. Maybe I'll have you guys do that soon. Or you don't see like the human cost on human life from mining this coal. So we have to include those costs in the actual cost, which is going to make energy prices go up. But, I mean, it has to. It's going to anyway. If we use a mix of renewables like solar, wind, water, and biofuels and geothermal, that can really reduce pollution, which is a huge problem, greenhouse gases and biodiversity losses. We can't just flip a switch and say we're never using coal or oil ever again. We can't. Right now, we cannot do that. But if we start making sure we use more of a mix of all these renewables, we can lower our dependency on these non-renewables. And then we've got to do a lot of things to get to be sustainable. We're not there yet, and we're not going to be there anytime soon. And when government and money is involved, And remember, all these, especially coal, for example, they make a lot of money. This is big business. Because of that, things aren't going to change. If people are making money, things aren't going to change for a long time. So think about that. And as you're working on your research with renewables and non-renewables and making your little superhero, think about the things that we've talked about and what's good and bad about each of them, because that's going to have to be what you know. All right. Well, I hope this all helps, and I will see you later. Bye.